In this video, I'm going to show you how easy it is to define complex objects like tables and grids across an array of platforms including PowerBuilder, .NET, the iSeries, web browsers, PDF, along with a custom table. You'll see that the same table definition structure is used across platforms. Let's start with PowerBuilder. In AscentialTest, object definition starts with something that we refer to as a snapshot, which is proprietary technology that's part of AscentialTest. The snapshot is a graphical representation of the application, along with a full hierarchy, all of the elements, and the attributes of those elements. I'm going to take the All button that we painted onto this snapshot and drag it and drop it. When I do that, notice that it defines not only the dialog box, but also the elements in the dialog box, including the PB table, which is what we're interested here. AscentialTest recognizes the rows and all the columns. We've created a special component of the table interface called a selector that makes it easy to select a row in a table based on a value in the row. So if I come to my test value field and put in 109, you'll notice that it finds the row where the customer ID equals 109. The user can constrain the search to only a single column, and you can combine multiple selectors together. There are also keywords like first, last, and random for row selection. Now let's take a look at a web table. Since there is so much variation in how to create a table in a web application, we created a wizard to determine the components of the table. This is not artificial intelligence. It's real intelligence built right into the AscentialTest object recognition. I'll start the wizard by clicking on this button. The wizard then has a dialog with me, the user. It's asking me to drag a rectangle in as much of the table as possible. So I'll drag a rectangle. And then it asks me to confirm that it identified the table. And it has. Does this table have a header? Yes, it does. It's prompting me now to drag a rectangle inside the header and then confirm that it accurately identified the header and the elements inside the header. Next, it asks me to drag a rectangle in as much of the first row as possible. Once I've done that, I'll select yes. Then it's going to ask me to drag a rectangle in the second row, which I've done, and ask me to confirm that it's identified the second row and all the elements in the row. So I'll press continue. Next, I'll take that table and I'll drag it over and drop it under the web page. You'll notice that AscentialTest defined the table, the header, all the elements of the header, the rows, all of the columns in the table, and it's given us 3 selectors, one for each of the first 3 columns. The user can add as many other selectors as they like. Here are some other table examples. This example is a .NET table. You can see that AscentialTest has defined the WPF grid, all of the rows, the columns, and we've provided a selector. I've put in the text Bill Bailey to show you that it can find the row where Bill Bailey is in the name column. Here's an example of a table in a PDF application. We recognize again the rows, the columns, and the selector can identify the row based on a value in the row. I've put in customer number and it found the first row in the table. Here's an example from the iSeries. And again, I put in a value for the selector, D01, and you can see that it's found the second row in the table based on that value. This last example is custom. It's not really a table at all. It's just text lined up in rows and columns. But AscentialTest can construct a table definition from anything that looks like a table, using another technology that we developed for parsing strings from the information available in the window manager. Just like on the other platforms, AscentialTest recognizes the rows, the columns in the rows, and provides a selector for locating a row based on a value in the row. I've put in Thriller, and it found the row in the song column. Our table interface makes it fast and efficient to build tests that interact with complex objects, like the tables that we've just reviewed.